Hi there, welcome to my YouTube channel. Today I'm going to speak about a theorem which is really important in electrical engineering. That said has to be Thevenin's theorem. So a scientist, like before I said, a scientist named Thevenin invents this rule. So he checked out the different circuits and diverse things in different circuits, and then conclude that something common is to the whole linear circuit. So the word of linear is important here because this rule is only uh, between all the linear circuits are true. So the Thevenin theorem is said that if you have a complex linear circuit, it should be a complex or a simple, you can replace it by a voltage called voltage of Thevenin or Thevenin voltage, which has been series with a resistance which called Thevenin resistance. So we have only two elements: a voltage source or Thevenin voltage and a resistance or Thevenin resistance. We can write them as V of the H, V with the index of Th, and R of the H, R with the index of Th. And the terminal of these circuits are open. So we have an open equivalent Thevenin circuit. And finally, we have to uh, track all 2 points of the open circuit into the between two terminal of both. So we have a V of Thevenin and R of Thevenin and a load. By doing this, we can easily calculate the current and voltage and some other things we need to know about the circuit and uh, use it from, for example, in complex circuit and complex network. So why is it useful? Because that we have a large complex circuit and it has consists of uh, some passive and active and some current source and some voltage source, resistance, and some other things. We can replace it easily by uh, equivalent Thevenin circuit. So the Thevenin circuit or Thevenin theorem says that we can do it by two or three steps, which I said to you in a few minutes. So how do we find the voltage of Thevenin and resistance of the Thevenin? For doing this, we should know that an open circuit and a short circuit. An open circuit is two terminals that don't have any tracking between them. And a short circuit is said to be two terminals that connected together with a wire, with a simple wire. Uh, it means that the resistance between two terminals is zero, and they in real connected with a wire. So how do we get to Thevenin voltage? To get the Thevenin voltage, we should use an amplifier. Uh, sorry, we should use a voltmeter to put it on two sides of open circuit of Thevenin circuit. We can get the voltage Thevenin of the circuit, and that number is related to Thevenin voltage. And how do we get the resistance of Thevenin? To do that, we have two methods. The first method is to assume that we neglect all the uh, independent source as zero. So independent voltage source should be short circuit, and independent current source should be open circuit to assume to be zero. After doing that, we can uh, calculate the equivalent resistance from the rest of the complex circuit we have after doing that. And the second method is uh, to use the voltage of the Uh, suppose that we have voltage of Thevenin from the previous section. So we have voltage of Thevenin, and it's just to short circuit two terminal of Thevenin circuit. By doing this, we can have the amount of short circuit of current. We get it by using an ampere meter. So the number of ampere meters showed us the amount of short circuit current. So by dividing the voltage of Thevenin by the current of short circuit, we can get the resistance of Thevenin. So these are two methods we can use to get the resistance of Thevenin. For example, suppose that we have uh, an independent voltage source amount of 12 volts, and two resistance amount of 4 kilo ohms and 2 kilo ohms. Suppose that the end of this circuit is open, so the voltage of Thevenin is considered uh, 12 volts. Consider we don't have any circuit between the elements, so the voltage of Thevenin is 12 volts, and by uh, cancel the independent voltage, we have zero in the voltage, and the equivalent of our resistance is two parallel resistors. So 4 kilo ohms and 2 kilo ohms in parallel bits gives us the amount of 4 times 2 divided by 4 plus 2. So 4 times 2 is equal to 8, and 4 plus 2 is equal to 6. So the equivalent resistance is 4 divided by 3, or 1.3 kilo ohms. So these are the voltage of Thevenin and resistance of Thevenin in this example. And the application of the Thevenin theorem is from complex complex tracking of network to calculating the power system and to uh, making equivalent resistance giving to a speaker because we need an resistance that is equal to uh, the resistance of the speaker to give maximum power to that and these are also useful in uh, mathematically and electrically calculation in our circuit device. And these are useful uh, some useful using of these circuit and theorem. Okay, I hope you all enjoy this session. Until the next video, have fun and goodbye.